In the question, radius of small sphere small r0 and radius of the track capital R0 is given. We have to find the angular velocity of the sphere after passing through an angle 125 degree and net acceleration of the sphere before leaving the track. In this picture, we have drawn a perpendicular line along this. We have assumed the point as capital B. Also, we have assumed this angle as theta. From energy conservation law, we can say that the total energy along this point A will be equals to total energy along this point C. From here we can write total kinetic energy at A point plus total potential energy at A point will be equals to total kinetic energy at C point plus total potential energy at C point. By putting the values, we get total kinetic energy along A point, that is 0, plus total potential energy along A point, that is mgr0, will be equals to total kinetic energy along C point, that is half mv square plus half I omega square, and total potential energy along C point, that is mg r0 plus, as this distance is r0 minus r0, so this distance will be r0 minus r0 cos theta. So we can write it here as mg r0 minus r0 cos theta minus. Now from this line we get mg r0 minus r0 cos theta equals to half mv square plus half I omega square. Now for sphere, we know moment of inertia I equals to 2 by 5 m r0 square, and the value of angular velocity omega equals to v by r0. By putting the values, we get half mv square plus half multiply 2 by 5 m r0 square plus v divided by r0 whole square. By taking common, we get half plus 2 by 10, r0 square will vanish. So from here we get 5 plus 2 mv square is equal to 7 by 10 mv square. From this we get the value of v square will be g r0 minus r0 whole bracket cos theta multiply 10 by 7 equals to v square. So we can write it as v equals to root over 10 by 7 multiply the value of G will be 980 centimeter per second square, and the value of R0 minus R0 will be 26 minus 1.5 into the value of theta will be, from here the value of theta we can write as the whole angle is 125 degree and this is perpendicular line, so the value of theta will be 35 degree. From here, by putting the value of theta, we get the value of phi, that is the value of cos 35 degree is 0.8191, and from here we get the value 24.5. Now by calculating this part, we get 1400 multiply 24.5 multiply 0.8191. The final value of phi is 167.6 centimeter per second. Now from here we can get the angular velocity omega equals to phi by r0. From here we will get, by putting these values, is 111.74 radian per second. This is the value of angular velocity. Now for the second part, we know the relation between linear velocity and acceleration, that is v square equals to u square plus 2as. Now here v is the final velocity, u is the initial velocity. So by putting the value of v, we'll get 167.6 whole square. The value of u is 0 and the value of s will be here, x0 we have assumed. Now first of all, let's calculate the value of x0. That will be, as from this picture, sin theta will be x0 by r0 minus r0. So we can write it as x0 equals to r0 minus r0 sin theta. Now by putting the values, we get now from here the value of a we will get divided by 2 multiply x0. By putting the value of x0, we get the final answer, that is 999.49 centimeter per second square. We can write it at approx that is 1000 centimeter per second square. So this is the final answer. This is the acceleration before leaving the track.